In this lesson, we're going to review the servlet-based implementation of the prediction service. It's a REST-style service, of course. And to that end, you're looking at one of the working files. It's called servletreview.txt, and you're seeing it in my Emacs editor. So let me begin with a very quick code review. The servlet implementation has three classes, the simplest of which is prediction.java. That's just a straightforward Java bean with three properties. An instance of a prediction.java represents a single prediction, of course. A bit more complicated is predictions.java. This basically is where the sausage is being made. So this is a utility class. It does the sort of low-level, grimy work that has to be done. So, for example, it reads the data out of a text file that's embedded in the WAR file, predictions.db. It reads those predictions into the Java data structure. So most of that code is utility code. The centerpiece, and this is also high level, is predictions servlet. This, in web service jargon, is the HTTP endpoint, which emphasizes that every incoming request hits this servlet instance. So the features of the servlet that deserve review are the following. First, the servlet supports the four CRUD operations. So post to create, get to read, put to edit, delete to delete. And as a further measure, the servlet explicitly rejects any other type of HTTP request. So, for example, trace and options are two other HTTP verbs. Should a client send a request with one of those verbs, the client is going to get a method not allowed error. Finally, this is a foretaste of what we'll see in the JAX RS and RESTlet implementations. The GET requests in the servlet allow two different types of response document. By default, the requester gets an XML response, but if the requester so desires, the requester can get a JSON document instead. And we'll be spending more and more time on JSON documents. Now, one feature of the servlet is a bit tricky, and that's the thread synchronization. So let me review that very quickly. Tomcat and Jetty follow the so-called one thread per request model. So an incoming client request is handed off to a separate thread for execution. So far, so good. The problem is that there is a single instance of the central data structure, the lookup table, that holds all of the predictions. So we can't allow a condition such as this. We can't allow two incoming clients, for example, to edit the very same prediction at the very same time. So we need to coordinate or synchronize those threads. Java has some wonderful data types for doing that. One of those, I'll highlight it here, deserves a little emphasis, is the concurrent hash map, which bakes the synchronization into its access methods. The concurrent hash map is also highly efficient. It's really a very well-designed type. The other synchronization construct is the atomic integer. Let me highlight that as well. The atomic integer ensures that every prediction is going to have its own unique ID value. Those values are generated from the atomic integer. Now, the predictions2 WAR file is available among the working files. For convenience, it also contains all of the source code. So if you'd like to tinker with that source code and then redeploy, you have the source code in the predictions2.war file. And of course, you can use the Ant script to automate the redeployment.